So before we get started, I just want to tell you guys, especially you guys in the back, that I'm going to be doing some demos, and I'm going to be doing some demos of some stuff with some really tiny type. I'm going to try and use like zooming in things here a little bit to be able to show you some stuff, but there's going to be a little bit of eye chart going on. And to that extent, since we're in this very long room and you guys are way in the back, if anyone wanted to like migrate toward the front, you can wait till like later when we actually get to the demo-y bits, but I'd also be totally happy if someone sat right here. That's completely fine. You can turn around and hang out, but it may be a better experience to not be in the back when we get to the demo-y bits. All right, so we go ahead and get started. All right. So thanks for coming to this session. We are doing, this is Master Modern Authentication Troubleshooting. I think the title is perhaps a little presumptuous. I'm uncertain that you will actually master anything, but I'm hoping you will learn something. So we'll see how it goes. But so my name's Joe Kaplan. I'm an IT guy. I'm not a consulting guy. But I work in IT at Accenture. It's a big professional services company, and I've been there since I left college, so it's a pretty long time. One of the most interesting things that keeps happening to me these days is that the people who are joining the organization were born after I started, so that's sobering, is what it is. Yes. Well, yeah, and soon I'll work for one of them. So I'm an MVP. I wrote that book. I don't know if any of you have that book. Very cool. Thank you. I appreciate that.
Learned how to develop initially off of that book.
That's awesome. I love it. Brian made the snarky comment earlier. Thanks for contributing to the coffee fund. Yeah, the royalties are. This is not a great way to make a living, but I'm glad I did it, and I will never ever do that again. So my background in all this stuff is kind of weird. Like I come to the space more as an application developer than like an infrastructure guy. And I spent a lot of time in our IT organization actually working on building applications and focusing more on how to glue things together. I have recently moved over to our information security organization, which is an interesting departure for me. So I'm doing architecture work over there. And so the thing I like to say is that I'm trying to learn how to say no. I always felt like my job as an identity guy in IT was to find ways to say yes and make things work together, and now it's just no all the time. So here's what we're going to try and do. So we're going to talk a little bit about modern auth, and we'll do some like hand wavy stuff like what that is. And so I'm going to try and do an HTTP tutorial where I'm assuming that you know nothing about HTTP, and I'm going to try and teach you some basic stuff about it. And then I'm going to take you through a little bit on some HTTP debugging tools and talk about my favorite ones for Windows. And then I'm actually going to do some demos, and I'm going to try and teach you some stuff about actual modern authentication through the lens of troubleshooting HTTP with HTTP debugging tools. And this is getting very full, so that's very exciting. All right, so let's keep going here. So modern authentication, what does this actually mean? Essentially what we're talking about is authentication that's implemented with HTTP, and this has been something that's been emerging in this space for a while. I believe Microsoft gets the credit for coining this term, which is good because before the term was coined, nobody knew how to really describe this. Modern authentication doesn't really mean anything, but it totally works, so I'm good with it, and And yeah, it's like core to the entire Microsoft Services platform at this point. I think the other thing though is that Microsoft has their own like stack and way of doing this stuff, but this is actually really common to a lot of other platforms as well. Like you'll see this pretty pervasively through Google Stack as well too. And Microsoft's not the only one who's doing it. They're not maybe the only ones who are necessarily calling it this, and everyone's stuff works a little bit differently, but HTTP-based auth is the future. And let's just move on. So I think more interesting is why do we need modern authentication? So the problem with the old authentication, and I speak to primarily Kerberos here, our old friend, is that Kerberos is a TCP and UDP binding on a special port. It's not a friendly place for the public internet. As all the services move to the public internet, you need protocols and basically just like core networking stuff that's designed for the public internet. So the core networking stuff is really, I think, actually the HTTPS piece of it. The S is incredibly important for everything that we're doing. Sometimes when I look at people who have really poorly implemented SSL stuff, which there's a lot of that out there, I try to remind them like how the entire sanctity of everything that they're doing is really based on this notion that your SSL is actually secure. And if you screw that up, you've basically compromised the entire thing. But there's a couple of other really important points in this, though, that I think are worth mentioning. So there's this notion that's sort of emerged with federation technologies around this concept of externalization of authentication. It used to be very common, and you still see it a lot, that the app wants to log you in, and the app wants to take your username and password. So that model is pretty much, I would say, fundamentally broken, and it's one of the most important things that the application developers really need to understand, is that you don't want that to be your job, you want that to be somebody else's job. You want to be told who the user is, and you want to you want to have a high assurance that whatever they needed to do to get into your app, they can go and do, but you do not want to be doing that login. There's just a gazillion reasons why that's not a good thing to be doing. So this whole notion of externalization of authentication is incredibly important to the whole thing here. And then the other piece of it is around adding other experiences. So authentication used to be username and password. Maybe it was a smart card, or whatever your integrated auth thing was. But there's a whole lot more to it these days, that you need some flexibility around how you can change those experiences. So we have this notion of realm discovery. Type in your email address to figure out where you go to log in. In the cloud, that's actually one of the first things that you actually need to do, is figure out who's authoritative for my login. MFA is a common thing that needs to be added in. You want to have SSO features so that you won't necessarily need to log in all the time. So you need ways to be able to decorate that in there. Device-based authentication, and then you get into more compliance-related stuff like terms of use. Consent is another one that's also important, especially in OAuth. So all these other things that you want to be able to do, like the captive SSPR sign up, so many different things that you want to be able to actually put into the authentication workflow, that you need some flexibility around how you can do that. And the HTTP stuff is not necessarily perfect, but it's a great way of being able to sort of decorate the authentication process with all this stuff. Okay. So that's it on modern auth. Let's switch gears and let's start talking a little bit about HTTP. So just quick show of hands, how I'm sure there's a fair number of relatively skilled HTTP debuggers out here, and maybe some web programmers. There's also, I tend to find there's a fair number of people who the way the web works is actually somewhat mysterious, and you use a browser and these things just work, but the actual model behind it is a little fuzzy. So I'm going to actually just assume that you are one of those people as we go through this, but I want to try and get some of the basic stuff sort of covered here at a very, very high level as we start to take you through this. So the first main thing that we want to talk about is that we have this data flow. Everything in the HTTP world is based on these request-response pairs. There's this thing called a browser or a user agent. User agent's the more fancy way to describe that thing, which may or may not be a browser. But there's a client, the user agent. There's a server. The client sends a request, and then the server sends a response back, and that's it. Request response, and we are generally passing back data that is mostly a bunch of strings. Okay, and that's how the entire thing goes. We're going to ignore weird stuff like WebSockets and SignalR. That's out of scope for the conversation here, but that's it. It's things passing back and forth, request response. Okay, so that's primary concept number one. So the next thing I want to cover is verbs. So get and post are the primary thing. So basically, the client will do one of these things. It will make a get, or it will do a post. There's a bunch of other things it could potentially do, like put and options. Browsers generally don't do those things. Active things, and we'll talk about that a little bit later, do. But the verb is an instruction to the server as to what the request is about. Okay. Next most important thing, and the thing that we will probably spend the most time when we get into the demo bits admiring, are headers. Requests have headers, responses have headers. The request headers are a bunch of data generated by the client that describe the request and different things about it, and same with the things coming back from the server. It's a bunch of data about the request, okay, or the response. We're actually going to take an eye chart example, look at this here in a sec. So then also there are bodies. So an HTTP message may or may not have a body to it. Requests generally, like a GET request generally will not have a body, but a POST generally will. And then generally speaking, a server response will have a body to it. Not always, but in most cases, servers always have both a header and a body. Or server responses have header and a body. Okay? And then the final thing that I want to cover, response codes. So whenever the client makes a request, the server will generally respond back with a code which indicates some status, and there's some sub-status that can go along with that as well too. But the primary response codes are like 200, 302, 401. There's a whole bunch of them, and you can go read the HTTP spec if you want to know them all. But the ones that you will be primarily dealing with in our world are 200, which means everything is just dandy. 302, which is a redirect. 401, which means not authorized. 403, which means forbidden, and there's like a healthy debate on the difference between not authorized and forbidden, and when to use what, especially in the API world that is perhaps going to be resolved someday. And 404, not found, and then 500 is supposed to be application level error, which is also sometimes helpful. So that is your crash course in HTTP basics. Let's see if we can make this a little bit more concrete. So I just grabbed some stuff from one of my demos earlier and threw it up here because I wanted to actually show what we're talking about. So on the right is a GET request. This is actually a request to Azure AD, and we will maybe talk about that a little bit more in a bit. But as you can see, well, maybe you can't see, I don't know, so there's a get line with a URL that's being requested. And I actually didn't really mention URLs. They're important. That's the thing that you're requesting. So yeah, we'll just move on from that. There's a bunch of headers over here. So we see that all these things being sent by the client are the request headers that I was referring to. And there's some real common ones in there, like accept and user agent and connection and cookies. There's also some weird stuff in there. We might go back and talk about what some of the weird stuff in there is later. And then the server responded back. In this particular case, this is the actual matching response from this particular request. So it gave me a 302. 302 is a, yes, you guys are listening, or already knew that. And so with a redirect, there's also this location header. The location actually tells the browser where to go. So that is exactly how redirects work. And there's a bunch of other stuff in there that is useful. And then the actual body was compressed, and I just left it compressed. I didn't. Could have been. I could have decompressed it with the tool, but that's actually typically done by servers in order to conserve data on the network, and that's something you will occasionally need to deal with and play with your tools to actually be able to see what that was. We good here?
Question.
Yeah.
What kind of a tool allows you to look at this? Because aren't these mostly HTTPS and supposedly?
Oh, we're totally going to get to that.
Okay.
That's coming up. That is a great question. All right. We're going to dwell on cookies for a little bit. I think it's especially important to spend some time learning about and thinking about cookies, because cookies actually drive a tremendous amount of the behavior of how these systems work, especially with browser-based scenarios, but surprisingly a lot with some of the active components as well too. And the better you understand cookies, the more likely you are to be a successful HTTP troubleshooter. So we're gonna dwell on this a little bit, if you don't mind. So first of all, what's a cookie? So a cookie is basically just a piece of text data. And it's part of the HTTP spec. It's used by a server to maintain state between requests. It's an incredibly important, because we have these response pairs and they're disjointed, they're not connected together at all. If the server needs to know between the first request and the second request, if it's the same person or any other kind of thing, cookies are the primary way that a server is going to actually maintain state. The way that they are set, and we'll actually get to an example of this. So a server can basically give a cookie to a browser through what's called a set cookie response header. And I'll show an example in a sec. And there's a bunch of flags that come with this that are actually pretty important to understand. So there's usually going to be a cookie name and some data associated with it. There's a path, which indicates the scoping to which the cookie is actually supposed to be returned to. So it basically matches up against the URL. There's also a domain. So a bunch of these things are actually optional as well too. They may not always get set, so there's some default values for them. But a domain scopes the thing that basically the host that the user agent of the browser is supposed to send the cookie back to. So generally speaking, if this is left blank, it's supposed to be just sent back to the same host that originally sent it. But there's some other interesting things that can be done related to scoping to host names that you can actually do on the server side. So expires is incredibly important. Expires is the thing that determines whether the user agent is supposed to store the cookie or treat it as a session cookie. Okay? And there's basically two different mechanics in cookies. There's this notion of a persistent cookie, and it's indicated to the user agent that something should be treated as persistent if it has this expires header set on it. So what's supposed to happen is that the browser or user agent is supposed to store that in its storage wherever it is, and then may replay that up until the expiry date. in between sessions. So if you close the browser, reboot the machine or whatever, that state is supposed to stick around until the expire date. A cookie without an expires header is treated as a session cookie, okay? And a session cookie is supposed to just basically stay in memory with that particular browser process, and will go away after the browser closes. This gets really complicated on modern browsers because they maintain session state in really interesting and different ways. Chrome especially has this cool thing where it runs a background process where it stores all of your session state. So if you close Chrome, all of your session state actually stays in this background process. You can turn it off, but it's on by default. And so your session state doesn't necessarily go away when you close Chrome. IE is a little different. It has its own background process, but it kills off all the state after you close it. So the state is maintained differently between different browsers, but the main thing is that the state is not supposed to exist, at least outside of full process restarts. Okay? Let's see, what else? The other two flags are also really important from a security perspective. Secure means that the cookie, it's an indication from the server that the cookie should only be sent back on a secure channel. Generally speaking, if you're building web applications that are supposed to be secure and that you use any security scanning software, you will get flagged by not setting this on pretty much everything these days. And with the stuff that we tend to deal with in the context of modern authentication, you generally should be seeing the secure attribute on everything. There are really very few exceptions to where that should be done. There's a standard cookie clearing behavior, though, where this frequently gets turned off. I don't know if I'll actually get to that in more detail, and then HTTP only means that the cookie is only supposed to be sent by the browser, but it's not actually, the cookie data is not actually supposed to be accessible to the JavaScript DOM. And this is actually an important thing from a browser security perspective because this attribute protects that cookie data from a variety of common browser hijacking scenarios like cross-site scripting. And so you'll generally see this used pretty liberally throughout the modern authentication stack as well too. All right, that was a whole bunch. Deep and cleansing breath. And does anyone have any questions? You guys are so good. All right.
Just from your comment with Google versus Internet Explorer or Edge on the cookie storage, that means basically Google makes the session-based cookie persistent at least until reboot of the machine.
Until reboot of the machine, or if you kill that process, yeah.
Exactly. And in Edge or in Internet Explorer, does Microsoft tries to do the same, or do?
So Internet Explorer, if you terminate Internet Explorer, all your session state goes away. Yeah. And Internet Explorer also has this kind of neat feature I use a ton for testing called New Session, which will fire up a browser with a completely separated session boundary from a memory perspective. It's really, 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 really useful for testing. It has no hotkey, which is super annoying, so you have to enable it through the menu. But
are you referring to the new Edge, or are you
no, this is IE. I don't use Edge a whole lot at work because we have not deployed it yet, and that's where I do most of my HTTP debugging. So I have actually a pretty foggy notion of how Edge does most of this stuff. All right, examples, more iChart. So we're starting on the server side. So the server side's on the left here because cookies always start from the server. Cookies always. I could. Well, let's see. I'm uncertain what it's got me in presentation mode over here. I don't know what's going to happen if I gate it. All right. First of all, so let's actually take a look at some of the headers and go through this a little bit. So we have so first thing to know is that set cookie headers.
It usually stays there. I'm not sure what your machine does.
I'm not sure what my machine does either. All right, well, we're just gonna roll. It's gonna be what it is. So first thing I want to point out is that on the server side in the response, set cookie headers contain one cookie each. On the client side, on the request side, the cookies are all compressed together into a single cookie header. Slight difference in how the data is modeled. So we see a set cookie header, and there's so we have this. The cookie is named BUID. This is an Azure AD cookie. I don't actually know what it does, but it must be important. Has some data, which is so it looks like some base 64 encoded gobbledygook, and there's an expires header. So this means that this is supposed to be treated as persistent, right? Okay. And it has a path set. It does not have a domain set, which means the domain implicitly is the same thing that this came from, and has the secure and the HTTP only flags. Okay. Down below, we actually have one that does have a domain set. So it's login.microsoftonline.com, and but it's not persistent. It's session. All right. No expires header or flag, and then. Yeah, a few other things. The gateway slice is that's part of Azure Compute. I don't. Hopefully, you'll never need to know what that is. I certainly don't know what that means. Okay. So then, what happens on the browser side is that the browser just sends the cookie and the data. The flags are just instructions on when to send the cookie. And it basically looks at the request and says, should I send this cookie back if I have this cookie? And based on all of these things, like if the cookie was sent to it secure, it's only supposed to send it back if it's requesting on an HTTPS connection. So it will only send that back. If it's following the rules, it will only send that back on an HTTPS connection. If the request is for the wrong path, it won't send it. But generally, paths that are set to the root will always be sent. Here's actually something worth pointing out. So I have run into many funny problems in the Windows web stack over the years. So in HTTP, URLs are case sensitive. And this attribute is also case sensitive. Windows or IIS, bless its heart, has always wanted to treat the file system like the Windows file system from a case sensitivity standpoint, and will treat by default all of your path-based URLs as being case insensitive. This can cripple you with cookies and paths. If you end up with any case sensitivity variations, like especially if the user just types the URL slightly differently, you'll still do the get, but you may actually drop a cookie because of how you pathed it. So my recommendation is in the IIS world, always use all lowercase. It's one of the only ways to be 100% successful with this. Especially if you're doing any path-based cookie scoping, which occasionally you need to. But it is one of the weird traps on Windows. Is it trying to help you? They play with the HTTP spec just a little bit, and you can step in a bucket really easily and have weird things happen.
Is the spec to be case sensitive or insensitive?
Case sensitive. Yeah.
That's always a terrible idea.
Yeah, it is. I mean, that's kind of the story of IE in a nutshell as well too. Like trying to do things to help that didn't really follow the spec and ruining everyone's life on the web for like a full decade. So anyway, the main thing here is the cookies are all blobbed together, and if you look for the semicolons, you can kind of see them separated up there, but that's how the cookies come back across. This is a terrible way to view them. We will actually look at a tool that makes this a whole lot easier to consume when we get a little bit further along. Okay. Everyone feel good and comfortable with cookies? Excellent. Let's talk a little bit about this concept. So we have this notion of active versus passive requesters, and I don't know if anyone's heard this terminology before. Has anyone ever heard of the WS Federation PRP, passive requester profile? Okay, very good. So A passive requester is a browser. It's just a fancy term for a browser. And an active requester is a programmatic client. And so one of the things that's really important in how a lot of modern authentication works is understanding how, like, what is the client? Is it a browser or is it something else? And generally speaking, almost all OAuth requires an active requester because most OAuth stuff requires the client to be able to do arbitrary programmatic things. Generally speaking, most federated login stuff that you will see tends to be based off of passive requesters. It just follows the rules of browsers. Browsers do really simple things, like you request a URL, you get a payload back, it'll follow a redirect, it will chase down all the child requests that are referenced in that page. So if the page says, oh, I need this CSS and this image file and this other thing and all these other things to pull my thing together, the browser will happily compile that stuff together and render it. It'll also generally execute some JavaScript and it will return cookies, but that's all it will do. And it ends up being really important to understand what things are passive requester things versus active requester things. Most of the stuff that I will talk about when we get to the demo bits I'm going to do mostly passive requester things, but we'll do one active requester at the end. Okay? Does the concept make sense? Active requester versus passive requester? Good? All right. So this is not how you're going to learn what the protocols are. The protocols are a study in and of themselves, and that's just too much. I don't think I can really get to that. There's a bunch of learning that goes into this. But when we actually get into the examples, I'm actually going to take you through a little bit of it just to give you a bit of a flavor. And a couple of just like indicators that you will see though. So for example, WS Federation, the telltale sign of WS Fed is this WA equals WSign 1.0. If you see that, you're generally going to be dealing with WS Fed. There's some other, WS Fed's more complicated than that. There's a bunch of other things that go on, and I'm not actually talking about, this is a request to log in to a server. As part of the WS Federation flow. There's a whole bunch of stuff around how the tokens actually get exchanged, which is different from that, and maybe we will look at it. But that's kind of your telltale sign for that. And all of these parameters mean stuff, and you can definitely look it up and learn it. The one in the middle is the one I hate the most, which is SAML. I think this thing is a monstrosity. I can't wait for it to go away. And it is so abhorrent, but there it is. And yeah, we'll be trying to chase this out of IT for decades to come, almost certainly. SAML is a really amazing protocol. It's incredibly flexible, does all these really interesting things. It is more or less impossible to implement properly from a security perspective because it's based on XML schema, which is incomprehensible. Like, the spec does not make sense in and of itself. And the things that you have to do right in order to make sure that your actual tokens validate and that people don't do weird things with their payload, it's just incredibly hard for SAML to be done correctly. So I look forward to the OIDC future and hope that we get there.
I guess the key thing is it was there much before WS Fed was introduced by Microsoft, wasn't it?
They were like competing. They were going head to head at the time. Microsoft really failed to get WS Fed to go anywhere except on the Windows platform, and it's still floating around out there quite a bit. I like the simplicity of WS Fed quite a bit by comparison. It has some of the same flaws in that it uses SAML tokens generally in it, and SAML tokens are one of the giant buckets of SAML itself. The actual SAML token thing it's not good. There's just like so many ways that you can totally get that wrong in your SAML stack, and there have been a bunch of really interesting security research bits where people have taken like all the different SAML stacks and created these like weird fake tokens and like, oh, this one actually let it in and this one let it in and this one let it in. And they all got it wrong except for like one or two of them. I think it was like the SharePoint implementation and OpenSAML PHP, remarkably. It was this one paper I read a while ago, and I just saw another blog post recently about somebody else's broken SAML implementations, but these are done wrong with an alarming frequency, and it's just really hard to get right. So here's the GET request to ADFS again for a SAML request, and you see it's just a blob of data. You can't actually read it. SAML moves things around in these XML payloads, which are generally big, and they don't fit on query strings very well. There's a bunch of restrictions you have around how much data you can pass around in your headers. And so they use this thing called, they basically are using some inline compression technologies. So you will need some stuff to do this thing called deflate SAML, which I'll try and show you a little later to actually see what's inside of that. But there's like there's a blob of XML in there telling it to log in. All right. And then here's an OAuth request down below. These generally tend to be a lot more human readable as well too. This is the one I understand the least, and we won't talk about it a whole lot, but generally you're going to be seeing requests for authorization with authorization codes and stuff like that in SAML. There's also a lot of use of things called bearer tokens and authorization headers. Okay. So it's not even really totally clear what we mean by OAuth. OAuth is definitely not a standard by any means. Like literally, if you pass a bearer token that has the word foo to a server that will accept it, then that's OAuth, but OIDC is actually a little bit more spec'd out than that and makes a little bit more sense. We're just going to ignore this problem because in the Microsoft stack it does actually tend to mean some pretty specific things. All right. Taking another deep and cleansing breath, let's talk a little bit about tools. Okay, so for the Windows platform, there are two tools that I like. There is Fiddler, and there is a thing called HTTPWatch. So who here is Fiddler? Everyone has it on there. If you guys are already Fiddler users, I have no idea what you're actually going to learn in this session, but we'll find out. Who uses Fiddler every day in their work? Okay, so there we go. How many HTTPWatch users? Anyone? Is that just me? A little bit? Okay.
Now, why don't you, Chrome's debug tools.
Chrome debug tools are actually serious and really useful as well, too.
I think they provide pretty much the exact same thing that HTTPWatch does, but just for Chrome.
Yeah, I think that's probably fair to say, and I don't use the one of the things with HTTPWatch is that they actually their release now supports Chrome, and I like the HTTPWatch UX a lot. The Chrome debug tools I frequently get close to what I'm trying to do, and then it's just I don't know, they could have done a little bit more, but it's free. I don't know, it's good free stuff. I should probably include that in there, except that these are the tools that I use, and I basically almost never use that unless I'm stuck in a very Chrome specific problem. And now that there's HTTPWatch for Chrome, I would probably still use that as well. But the Chrome debug tools can also do a whole bunch of other really interesting and useful things as well. So let's talk a little bit about the tools and so I think one of the most interesting things from this is if you look at it, Fiddler's free and basically does everything, and there's a whole bunch of limitations in terms of what you can do with HTTPWatch. So it's kind of weird. I always use HTTPWatch first over Fiddler because I think its UX is great. I find it super, super productive, and I will frequently actually do something in HTTPWatch, and then I'll just flip over to Fiddler just for like one little thing. But I love HTTPWatch, even though there are all these things that it can't do. But let's actually go through it a little bit and talk about it. So one of the other things it's funny, HTTPWatch used to cost $69. And I thought, it was like, oh, it's only $69. It's like a pretty good deal. And so when I was actually putting my slides together for the conference, I was like, I should go over there and see how much the actual price is, because maybe they changed it. And wow, they really did change it. That's actually a really different a different bargain. They do actually have some pretty good enterprise licenses. We have an enterprise license at work. And so it's not something I usually put a lot of thought into, but that's a more substantial investment than it used to be. So it probably changes the calculation a little bit. But I'm still going to do some demos with it as we move forward here. So the main thing that is incredibly important about it is that with HTTPWatch, what you're doing is you're getting the traffic post-encryption, so it's already kind of inside of the browser memory, and this means that you don't have to worry about anything having to do with SSL, which is really nice. It's incredibly easy and useful to just jump in and grab, but you're restricted to IE and Chrome. So those are the only two things that, well, actually, no, it works with Firefox. I kind of lost track of Firefox because Firefox doesn't work with device auth in Windows 10, so I've just like given up on it. But it does work with Firefox as well too. But you can basically only do browser stuff with it. One of the great things with Fiddler is because it's a proxy, it works as a proxy in the operating system, you can proxy anything, which means that you can do all the browsers, but you can also do all the Office apps. And then the exotic use cases for Fiddler are that you can also have your machine be listening for traffic and basically work as a proxy server. You can connect a mobile device to it by basically making your mobile device use your machine as a proxy server and capture traffic that way. You can capture stuff on the network that way. You can capture stuff off of Macintosh. So you can do a bunch of really interesting exotic scenarios with Fiddler that you can't really accomplish anything else with anything else. The downside with Fiddler is because this is modern auth and all of our traffic is encrypted, we're now going to be having to decrypt all of the SSL traffic, which means that it's a setting you just have to enable within Fiddler to do that, but you will have to be doing that. And because now you're also doing basically SSL man in the middle, you also broke all of your client certificate authentication, and that is frequently problematic. So there's some dancing that you may have to do to work around that. And this one of the key things I frequently end up looking at between the two is like, is client TLS actually important to my current use case or not? All right. And yeah, Fiddler's an amazing thing. There's like whole classes you can do on it. You can use it to modify requests. It goes on and on and on and on. In any event, that is my crash course on tools. I was going to move on to the next section now. Do I have any questions, or are we ready to try and do some debugging? All right, let's do this. So I'm going to sit down. So I'm going to do a couple. We're going to jump in and dig around in some traces just to look at some basic federated logins. I'm going to try and do these live with the conference internet here. So we'll see how that goes. It worked the last time I tried it. If we go suddenly fail, I have captured traces of these. One of the things too, while I talk about captured traces, so both of the tools have the ability to actually save sessions, and I find this to be incredibly helpful when I'm in IT mode. Somebody somewhere says, it's doing this thing and I don't know what's happening and I can't fix it, and they're on the other side of the planet and I need to know what's happening. I will typically say, I need you to install this tool. It'll be one of the two depending on what's going on. But I need you to install this tool, do this, and this, and then save the data. If your password's in it, I need you to remove your password from it, and then I need you to send me that file so I can look at it, and I will then use that as a technique for figuring things out. But the ability to get other people to basically ship you their problems so you can examine them offline is incredibly useful as well. And it's one of the most important things. So there's a lot of stuff that I tend to do that's actually really, really forensic, where I never actually saw the problem occur. I just get the trace and I have to figure it out. I just got an email from IT this morning saying we're about to start upgrading everyone to 1703 Creators 2. Which is really exciting. Like when you're planning to be tethering, like for the next couple of days, it's like, oh wow, it's like that's a 3 gig update that my SCCM is going to try and download. Thanks, IT. All right. So first of all, HTTPWatch. We're going to do this first. Once you have HTTPWatch installed, you're typically going to turn it on with this little menu option. Pops up this little thing down here. I'm going to move it out of the way. And we are going to, so this is a test application that we have deployed in our environment. It's out on the public internet, and we just use this for testing ADFS logins. And I will tell you a little bit more about it in a second, but I'm going to click on it. Doop, 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 doop. Stuff happening, and stuff happened. Okay. So, what just happened? I navigated to a URL. This URL required authentication from ADFS, and the ADFS policy was configured to require multi-factor authentication. You might have seen that little thing going by where verifying your device registration. That's not super relevant to the demo here, but we use this product called Semantic VIP. I don't know if anyone's ever heard of it. It's a multi-factor authentication product. We have a custom MFA provider integrated with ADFS, and this is what we use for doing all of our MFA within Accenture. We have it deployed to like 500,000 people, and it's on like 2,000 different web apps. It's such a giant MFA deployment, and it has this cool feature. The thing that you actually saw go by is it has this notion of device registration, where you can basically you install a little plugin, and once you've installed the plugin, the machine and then you go through like a bootstrapping process through an MFA challenge. What will happen is the agent will then have a credential that we'll use to generate an OTP that it will then also submit to the server automatically. And so basically it's doing an OTP login for you without any manual intervention. This is incredibly useful for making MFA seem a lot less painful, because ADFS's login state is session-based here, and so every time I close this browser, I would need to re-MFA into this, and that would be pretty horrible. All right, so and the test application is just a little dump out the claims thing. Not super important. Don't want to focus on that too much. I'm going to go back up and get into the HTTPWatch thing here a little bit as we go through this. All right. Yes. Let me see if Zoom it's working. Oh, Zoom it's working. Good. All right. Actually, this is good. It's throwing me off too much. Hold on. Let me move this guy up first. So the first thing that happened, we will start. Yeah, let's start here. So first request. All right. Does this help a little bit at all? All right. So the very first thing that happened is that I made a request to this URL over here, Federation STS. You guys can all test this right now too. It's on the public internet. See if you can get in. But this is the test application itself. And the test application, as you can see from the way HTTPWatch is displaying it, generated a 302. I'm going to take a quick run through the headers. I can't click on this and zoom at the same time. It kind of works, but it kind of doesn't. So let's zoom in again. Oh, really? I should have spent more time learning how to use that thing. All right. So here's the way HTTPWatch does this, which is super helpful, is that it actually takes all of the headers and separates them out into individual line items. And so we see that my request line is this get and the protocol. And then there's a bunch of other things in here. It's sending me sending a cookie for some reason, and it has a host header, a user agent. There's a little interesting thing in there. If you can see it. This thing right here, there's a weird string in my my user agent header, and the rest of this is just straight up IE11 in non-compatibility mode. But that is unusual. So what that is a thing that we have deployed in our environment that via group policy, and we basically configure IE to always add this particular value to the user agent header. We use this in conjunction with ADFS's feature, which is user agent based integrated auth fallback to forms. I don't know if you noticed, but I didn't do a forms based authentication there. So this is a little bit part of that magic. But in any event, and then let's look at the response headers. Oops. So in the response headers, we have our status line. So here's our code, some caching related stuff, the content type, the date. Date is an incredibly important header, especially for people doing federated authentication troubleshooting. I don't know if anyone has ever been in a debate with a service provider around why your SAML isn't working because of clock skew. Clock skew is frequently a problem in federated auth. It's a problem in all authentication things. Everyone actually has to agree on a clock. It's also sadly the case that a lot of people can't get their servers to synchronize to a valid time source in their data centers. It might be you, it might be your service providers. The way to find out is to look at the date headers. So, and there's a really, really simple way to troubleshoot these problems. All you need to do is look at the date header, make sure that the date is the actual time. Your phone is probably right because they're usually pretty good about that. You may have to do some UTC math. And basically, these things all have to be the same, and they all have to be going up by milliseconds or seconds. And if they aren't all basically the same and just increasing as the requests go by, somebody's wrong and it's their fault. And that's the end of the story. Somebody's wrong and it's their fault. And if it's you, then learn how to sync your servers to a valid time server, and don't tell the vendor it was your fault after you fix it.
In ADFS, it defaults to being right on, because you have to go back in and set it, like we set all our clock skews to be 5 minutes.
Yeah, well, so part of the problem is that you don't necessarily get to control what the other guy will accept. ADFS has its parameters around what it will accept, and they use there's a philosophy in this, issue strict and accept loose. And some people issue loose and accept strict. They just basically do it the opposite. But there's just plenty of opportunity within the spec for people to get this stuff wrong. And occasionally you'll just see people with clocks that are just like whacked. But a lot of times the more subtle problem is that somebody's clock will be just like a few seconds in the future. And that's just enough if they, with a not before clause in your SAML assertion, for that to just blow up. So in any event, that is a thing, and that's an important and useful thing, is to look at the date headers. Okay, that was a little bit of diversion, but let me kind of run through this real fast. So the first thing that happens is that I do this GET request. The location. So location header redirects me over to this ADFS with an instruction to log in. This is the application's job to know how to do this, and so then it's ADFS's job to log me in. You'll see that the first thing that happens, I'll zoom in again. We'll just go through a little bit of the flow here. The first thing that happens is that there's a 302, so it redirects me and it changes the URL from ADFS LS to ADFS LS WIA. WIA is the integrated auth endpoint for ADFS. So that the thing I was just talking about, where we pass that user agent in, this is basically the way we do this is not inside or outside of the network. Everything is outside of the network from our perspective. What we do is, if it's a machine we manage, then we're going to do integrated auth, and if it's not, then you're going to get forms-based authentication. We actually have a custom extension for Chrome that does this, which lets it use its integrated auth as well too. So basically what happens is there's an authentication dance here. The 401's bouncing back and forth. That's an NTLM handshake that happens. Never mind that this isn't Kerberos. That's a sad fact, but it's just what's happening. Okay, so then the next bit of things that are going on here are that I'm being redirected over to our semantic VIP stuff. So part of semantic VIP involves a bunch of resources that they host in the cloud. So it's actually our server is actually doing the authentication, but there's this really crazy JavaScript thing that they have that implements a bunch of the logic in the browser, and that's actually sourced directly from their server. So the thing's configured to go get that. So I see that I'm jumping over to this user services.vip to grab some stuff. The really relevant one is this one, and there's some Accenture-specific GUI in that URL that's based on some config. But basically, it does its thing, and then there is a post that eventually happens. I'm not going to show you what's in the post, but the post actually contains the code that I mentioned that the VIP generated. That's why I'm not going to show it to you. And then because ADFS is either clever or stupid, it needs to redo my integrated auth, possibly because if this is on a different browser, a browser thread, NTLM auth is actually tied to the TCP port, and if you have different threads open and you switch, you may in any event. Because of the way that statefulness is maintained at the TCP level, you may have to re-auth there. So we see another integrated auth dance, and then eventually what happens is that ADFS is going to give me a 200 response, which is interesting because that's actually just a payload. And so then the thing that happens next is weird, but let me show you actually what the contents of this payload are. So there's basically a body here, and this body, there's a hidden form in here with an action that says go here, and then there's a little bit of JavaScript embedded in this that says when this page renders, I want you to execute this JavaScript, which basically posts this form to this URL, and this is basically the magic of federated auth, is this little JavaScript bit, and this thing here, this form, is the SAML token. In WSFed, it's called a RISTer, a response to security token request. And we can actually, with these tools, go in and just grab it right out if we want.
Can you
add to where did the VIP service, that semantic service, hand over the MFA code, is that the last section, or was that the first time you connected to it?
The post to do the MFA code, I believe.
Don't want to see the code, but I think that
It was
that
this one.
Probably before, right? And then the next thing is probably after that is your authentication. Then.
Let's just look in here. Yeah, this is that's the code right there. And it had to repost it a couple of times because there was an integrated auth that happened, but that's where it happened.
Okay.
And that was executed by the JavaScript. All right. So then, and what happens here? So this is interesting. So then the browser does what it was told to do because it's a passive requester, which is to execute this post. And the post, we can look at it from a content perspective. Actually, let's look at from the stream perspective. There's just so this is a request with the body because it's a post, and it has this thing which is the wrister in it, which is basically it contains the SAML token and a little XML wrapper. HTTPWatch makes it super easy to actually go in here. Actually, I'll just go to the post data. You can actually just right-click on this, copy, drop it in a Notepad document, save it as a .xml, and then just examine it to your heart's content. See all the claims that are in there, all that stuff. So incredibly helpful and useful to be able to do that. And it's also, I guess the thing I really like the most about HTTPWatch is the way it decomposes everything in all these different bits and pieces and makes it really easy to grab the data in a lot of different ways. Fiddler kind of does this, but I think it's a lot more clunky. I just feel a lot more productive with this tool doing this kind of stuff. I'm totally going to run out of time. So let me, let's see, what shall we do? I'm going to do a quick SAML one that's kind of the same thing, but a little different. And then I will do my last demo, and then we'll wrap up. Okay? Is this helping? It's really kind of difficult to go from here's a basic explanation of HTTP to jumping in and actually trying to comprehend what's going on, especially for the people in the back where this is a super eye chart. Yeah.
So I'm seeing that these tools can be very useful, and one can learn what flow means. But what I want to know is what can go wrong and what should you look for. So you talked about the time skew. And are there other things that frequently go wrong and you can't do wrong?
So there's lots of things that go wrong. Actually, I want to do the device auth one too. That's my talk tomorrow is primarily about device auth, but I wasn't actually going to do any demos. Device auth is fraught with peril in this space. Let's just do one. But yeah, I mean, there's no magic grab bag of things of all the various things that can go wrong. There's just a lot of opportunity for lots of things to go wrong. And sometimes it's not so much that things are going wrong, but things aren't necessarily working the way you really think they ought to be. It'll especially be along the lines of, how come I had to log in again? And is this really as good as it can get? And trying to figure out little picky implementation details of, because some of this is making, is all about making things more usable and not just functional, especially in the MFA space where you really would prefer not to MFA everyone on every login, or else you'll all get fired. So yeah.
I just comment, if you use ADFS and you create a lot of single sign-ons with vendors, we get it all the time where users like, hey, this website, it won't authenticate, or they're not seeing the right stuff, and the vendor invariably is like, hey, you got a problem on your end, so how do you troubleshoot that, right? A lot of times, I can talk to you after this, but being able to decrypt the SAML payload to make sure that the data they expect is actually there goes a long ways to proving it's on their end.
Okay.
That's huge.
So quickly, let me try and let me show you this one. So this is the same web server. It has like a gazillion test apps on it. They're all configured a little differently. Oh, this is interesting. It's totally behaving differently than it did last time. Curse you, primary refresh tokens for your inconsistency. I actually may show you a trace that I captured this morning where it actually behaved differently. That wasn't so bad, but it still didn't work the way I thought it was going to. And what happened here was instead of, so this application is actually configured as an app in Azure AD. It's not an ADFS relying party. ADFS is the source of federation and login, but the app is actually protected by Azure AD, and it has a couple of conditional access policies applied to it. So it requires both multi-factor authentication, and it also requires managed or compliant device. And we'll talk more about that if you go to my talk tomorrow. But the thing I wanted to actually show you in this is, so I started with a fresh browser window. And I go to the app, and then I go to Azure AD, so login.Microsoft Online, and I'll zoom in a second. This is pretty trick question, but there's black magic stuff going on here with how device-based authentication works in Windows 10. See the AADSSO cookie? This cookie was sent by the browser to a server that it has not yet visited. That violates the rules of cookies. The rules of cookies are that I send back cookies that have already been sent to me. It's not a persistent cookie. If it were a persistent cookie, then it could have already had this state, but this is a session cookie. And it sent this before I ever visited the site to which it was sent. So this is black magic witchcraft that's going on here. See, the source is JavaScript. This is actually a cookie that was generated by Windows 10 through this component called the token broker. And so it's deep down in the bowels of the operating system. It got my primary refresh token, and it generated a token intended for Azure AD. It packaged it up as a cookie. It made its way up to the browser. So IE actually knows that it should send a cookie anytime I'm making a request to this endpoint. Just go ahead and send it. Don't even wait for it to ask. Just send it. And it sent this cookie, and then this cookie actually got rejected, which totally surprised me, because this morning it took this cookie and it actually just worked. My PRT keeps losing its MFA state, and I don't know why. So basically, so what happened was the cookie came back, it cleared it, which is this thing where it set the expires to yesterday. And because it rejected the cookie, and then it actually just relogged me in. Well, it actually didn't completely relog me in. It redid my semantic VIP because it rejected the MFA portion of my login, but that caused me to relog in again. But anyway, this is the thing I want to show here. Let's see if we can get the last one, which is my active protocol one, and then we'll try and wrap up. As you get involved in device-based authentication, which you will, because if you're buying into the Windows 10 journey, this is an incredibly important part of this. Black magic in the cookies is really weird the way this stuff works. By the way, there's like a thing for Windows, for Chrome now, this thing called Windows 10 Accounts, where this now works in Chrome. It didn't before, and you can deploy that via group policy in your organization. If you're Chrome users, you can actually turn that on for all your users. You have to be on 1703 of Windows 10 for it to work, but it will otherwise work. So you can get device-based authentication, managed compliant device on Chrome as well as IE and Edge, but not Firefox, and never Firefox. Okay. Last example. We'll do this quickly and then we will wrap. Okay, so I had this thing. I'm just going to actually show you a quick screenshot, and then we will look at the trace. So I had these people complaining to me. We're playing with Teams, and Teams is kind of like other apps that use ADOL in Office, but it's also clearly not. But so the thing that is weird about this is, if you see from the screenshot, there's a username and password box. Every other ADOL experience in Windows for us with Office, we get our normal integrated auth thing. And so why is Teams doing this? Why did it not do my single sign-on the way I expected to? And why did it do a username and password? So since this is Teams, this is a client app, so we're going to use Fiddler. I'm going to skip. So I took a full trace, and I have both of them here, but what I did was I used Fiddler, and I removed all the other junk from Fiddler. So the thing about Fiddler being a proxy is it's proxying everything, so there's a lot of noise in there from other stuff. So what I did was I just went through and I found everything associated with the process Teams here. And I just saved that off to a separate thing. So let me show you the craziness that goes on here. I'll try and take you through it quickly. So the very first thing that happens related to this login is that Teams makes an OAuth request to Azure AD. So here's login Microsoft Online as Azure AD, and we can tell it's OAuth mostly because it says OAuth 2, and we trust that they wouldn't make the WSFed endpoint called OAuth 2, but you can also see that it has that response type code in there. All right. And so then stuff starts to happen, and this thing gets redirected, which ends up back here. So it's changed the request a little bit. We're not going to dwell on that too much. And then I think I went through, do you want to use the new login UI? And it redid that. And so then I ended up back here at my ADFS. And here is the stuff that's going on. So let me see. Can we find, hold on. Switch over to here. Yeah, this will be easier to see. So in Fiddler, one of the things is, so in the query string that came back to ADFS for this WSFed login, the two things that I think are weird here are that there's a wfresh parameter, which is a not often used, but it's a WSFed thing that means you need to do a fresh login. And there's a wauth parameter, which tells you what kind of login it wants. And so it sets wfresh to 0, and it's also saying, if we scroll through there, that I want you to do password auth. And so what's happened here is that something has, from Teams, Word doesn't do this, Outlook doesn't do this, Teams does this. I think PowerShell does this too, actually. So why did it do this? And so then the question is this something I'm doing wrong? Is this something I have in Azure AD? Is it Teams? Whose fault is this? So after some research, it actually turns out that there is a feature in your federation settings for Azure AD where there's this thing, there's basically a default value on your federation settings called require fresh password auth. And if you don't change that, so if you're an ADFS 3 or 4 customer, you have the ability to change that setting to either native or disabled, which will give you a better login experience and also potentially enable SSO. But if you don't know that that setting exists and that you can use it, in my scenario, it will use this default thing, which uses basically like these lowest common denominator parameters that are compatible with ADFS 2. And this is the thing that's causing the problem, is this setting in Azure AD, which we have not yet fixed because everyone's afraid to change it because it's a global setting for Azure AD. So there's a lot of planning, and we're still in the middle of this. There's another problem with the Teams login where the semantic VIP isn't working, and I'm not sure if it's related to this or some other problem. But in any event, this is my active troubleshooting thing that I'm trying to work on right now, because if we're going to get Skype to replace Teams, I can't have this crap. This is super bad. But in any event, I'm pretty much out of time. I'm hoping that this was interesting and useful to you guys in terms of like getting inside of how I do this. I feel like I learned how to do this over the course of about 10 years, and I've tried to teach people how to do this, and it took more like 5 months, and so I think an hour and 15 minutes is a little ambitious. So uncertain whether anyone is walking out of here who didn't already know this stuff as thinking that they really mastered anything. But in any event, I hope it was useful to give you sort of a flavor of how you can actually use these tools to figure out what is going on in your modern auth stuff. And one of the great things too is that if you can capture a trace, you can send it to somebody who does know what they're doing and ask for help and learn that way as well. So,
What was this in Azure you were talking about, this global setting?
it's the MSOL federated authentic. I have it. It's your federation settings where you can also configure if you have if you supports MFA and all of your other key federation settings. But it's a global config object that you manipulate with PowerShell. And yeah, the default value is not what you necessarily want if you're on the right thing. We're almost out of time, and any more questions that you ask will be standing in the way of lunch, but I will happily answer them.
Sorry.
That's fine.
The magic cookie you've been talking about, so browser support, browse iOS and Android when you register these cookies.
I will talk about that a little bit more tomorrow. I probably won't get to the level of cookies. The main thing to know is that Windows 10 is different with all the device auth stuff. Windows 10 has special magic. That's actually one of that's the great value add of what you're paying for with Windows 10 is this stuff. I think it's actually one of the most interesting things. It's like it's integrated auth for the internet. This particular feature, and it's super cool, and I just love it even when it breaks right in front of me. But almost everything else uses client certificate authentication. I would expect that this will continue to change a little bit because you have some more flexibility in the mobile platforms with the ability to add like these sort of brokering applications that can do fancier stuff. But generally speaking, it's the token broker component of Windows 10 doing magic special sauce, and everything else has a client cert and using client certs.
So just to add to this, so when you have a Windows 10 and you have it added to Azure AD, so it is obtaining a special token at the beginning, so you have a long-lived token, and actually this token is used to request the other tokens, so it will not work the same way on iOS or Android, Windows 10 only.
So, and if you are interested more in the device-based authentication stuff, my talk tomorrow is primarily going to be about that. There won't be any demos; it'll all be talkie-talkie. But that's what my identity as a control plane thing is actually going to devolve into after we have the philosophical conversation, and I'll be talking a bit more about that stuff. Plug. All right, thanks a lot, guys. I appreciate it.